All right, so we're on the Unit 9, Part 2 review, quiz review. All right, so X is less than less than 8. Remember, whenever you have this situation with just less than, you're going to be using a dotted line. Okay, so be careful with that. Now, with a dotted line and X, remember, another trick for this is if you don't remember, just make some points up. And remember, X is always 8. So 0, 1, 2. So you go to 8, 0. You go to 8, 1. You go to 8, 2. If those were actually lined up, that'd be great. So 8, 0, 8, 1, 8, 2. And that should remind you, oh, we're talking about a vertical line here. Okay? So you make your vertical line and you make it dotted. All right, technically there should be arrows on both sides, so you get the gist. All right? Remember to use a straight edge, especially for the later part of this review and test. So in this case, we need to figure out where we're shading, left or right. Pretty obvious when it's a vertical horizontal line. Less than is going to be this way. And you don't have to shade in a lot. That's enough. That tells me which way it's going. Okay? Now for number 2, you have 2 ways to go about this. You can do the cover-up method when you basically plug in a 0 for X and solve for Y. 20 divided by 2 is 10. Or you plug in a 0 for Y and solve for X. 20 divided by 5 is 4. Whoops. And then you go to 4, 0. And you go to 0, 10. Now notice it's greater than or equal to, so we're going to use a solid line. I'm not going to stress over the arrows. All right? And then at this point, you test a point. When it doesn't go through the origin, the best point you can use is 0, 0. Okay, so we're going to test that point right there. Well, I plug in a 0 for X and Y, I end up with this statement. 0 is greater than or equal to 20. Is that true or false? Well, 0 is not bigger than any positive number, so that's false, which means I'm not going to shade this side where 0 is. I'm going to shade this side. And I'm done. Now, remember I said there's 2 ways to do this. You could have also solved for Y, slope-intercept form, by moving this over and getting 2y is greater than or equal to negative 5x. That's the only thing you got to be careful of. A lot of people are still making that mistake. Plus 20. Then divide by 2, and you get negative 5 halves x plus 10. So in this case, you'd start at 10 on the y-intercept, and you go down 5, right 2, and you go down 5, right 2. You would just have 3 points instead of 2 to connect. But if you're using a straight edge, it should not be a big deal. All right, in this problem, we have a transport company. We have type A and type B trucks. All right. It says type A has refrigerated capacity of 20 cubic millimeters and non-refrigerated of 40. Okay. While type B has the same overall volume with equal sections for refrigerated and non-refrigerated stock. A grocer needs to hire trucks for transport of 3,000 cubic meters of refrigerated and 4,000 of non-refrigerated. The cost per kilometer of type A is 30 and type B is 40. How many trucks of each type? Okay, so trucks of each type right there in the question tells you your X and Y are going to be type A trucks and type B trucks. And you want to minimize the cost. All right? So at the end, if we want to work this problem all the way through, we want to plug in the corner points and get the minimum cost. All right? Now, this is already filled out for you. You're just going to write the constraints. All right? So if you're working through, though, you would say, A and B is your X and Y. So you label those here and here. All right, I just realized there was a mistake when I was changing problems. Sorry. This should say refrigerated, and this should say non-refrigerated. I apologize. I probably have already told you in class. But basically it says type A has refrigerated capacity of 20 and non-capacity of 40. So actually I just got those backwards. I'm on a roll. All right. And then type B has the same with equal sections. Okay. So 40 plus 20 is 60. So that means it's 30 and 30. And then as you can see, it says grocery needs 3,000 of refrigerated. So that's why 3,000 is here with refrigerated, and non is 4,000. So if we're going to make our objective function, right? It's right here in this line with the cost. Type A is 30 and type B is 40. So that's 30x plus 40y. Our constraints, don't forget to do these, get these out of the way right away. Those are every one of these problems. Then you just pretty much read straight across. 40x plus 30y greater than or equal to 4,000, and 20x plus 30y greater than or equal to 3,000. That's it. That's all you're doing. Just baby steps. We'll do a final problem at the end. All right, given the following corner points, find the minimum and maximum. So all you're doing is plugging each of these in. So on the first one, z equals 10 times 0 plus 2 times 5. So that's 0. 2 times 5 is 10. Okay, z equals 10 times 1 plus 2 times 7. Well, that's 10 plus 14, that's 24. Z equals 10 times 3 plus 2 times 8. Well, that's 30 plus 16, that's 46. And then z equals 10 times 12 plus 2 times 1. That's 120 plus 2, 122. So here is my maximum, and here is my minimum. So 0.5 is my minimum, and 12.1 is my maximum. Now notice it says at. That means you're talking about the point, not this value. Similar problem except from a drawing. So first off, you need to find these points. All right. So I'll just start right here. This is 1, 2. Then we have 2, 5. And then we have 4, 5. And then we have 5, 2. Okay. And we're going to plug those all up into here. Now, I'm not going to show plugging in because I just did it, but it's basically going to be 2 times 1 plus 4 times 2. 2 times 2 plus 4 times 5, and so forth. And what we get is 24, 28, 10, and 18. So the maximum of 28 is at 4, 5. The minimum of 10, 2, 5. Sorry, I did these out of order from when I was calculating them. So 1, 2, my apologies, is 10. 2, 5 is 24. 4, 5 is 28. So I was right, I just had these in the wrong order. And this is 18. All right, and the minimum, therefore, is at 1, 2, which only gave us 10. All right, now one of these problems starts to finish. So B&W Leather Company wants to make belts and wallets. Each belt nets the company $18. That's the belts. And each wallet, $12. Okay? Both belts and wallets require cutting time and sewing time. Belts require 2 hours, so that's belts, and 4 hours for sewing. Wallets require 3 hours of cutting and 2 hours of sewing time. Now, the machine is only available for 12 hours per week for cutting and 18 for sewing. What mix of belts and wallets will make the most profit? So, that tells you right there. Just go in order. Belts and wallets. So, belts and wallets. I'm just going to abbreviate. Now, we have cutting time and sewing time. So if we look again, it says belts have 2 hours for cutting and 4 hours for sewing. Wallets require 3 and 2. Now the cutting machine is only available for up to and including 12 hours, and the sewing machine is only up to and including 18 hours. That's our table. Now, we look up in the thing for the profit. All right? And that is right here. So belts is 18. So that's 18x. And wallets is 12, so that's 12y. My constraints are what they always are. First off, to start off with. Put in the real world. And then we just go straight across. Okay? 2x plus 3y is less than or equal to 12. And 4x plus 2y less than or equal to 18. Now, once again, you can solve these for y or the cover-up method because 2 and 3 both go into 12 and 4 and 2 both go into 18. I'm going to do the cover-up method. Okay? So, if I cover up this, then 12 divided by 3 is 4. And notice it says count by ones. So, y is 4. So, I don't know what happened here, but the bottom line got cut off. So, we're just going to make this the axis right here. Not sure what happened. All right, there's my axis. So, y is 4. 1, 2, 3, 4. A nice dot. If I go up and cover this up, then my x, 12 divided by 2, is 6. So 1, 2, 3, 4, 5, 6. Right there. And I want to connect those with a nice straight line. Going back up. Now I'm going to go to this one and cover up my x. 18 divided by 2 is 9. So my y-intercept is 9. So I was at 4, 5, 6, 7, 8, 9. And then move this over here. Okay, I apologize. I'm going to roll. This was supposed to be changed to 16 to make the numbers work out better. So this should be 16 here. This should be 16, and now you'll see why, because now 16 divided by 4 is 4. So 1, 2, 3, 4. And now when I connect those dots, you can see I have a nice point right here of intersection. And that is at 3, 2. Now when I test both of these and plug in 0, 0, I end up with 0 is less than or equal to 12, true. 0 is less than or equal to 16, true. which means I'm shading underneath. So for this first one, I would be shading here. And for the second one, I would be shading here. So where is my area? It's right here. So that's 4, 0, 0, 0, 3, 2, and 0, 4. Those are my corner points. So when I plug these in to my objective function, I end up with 0, 48, 72, and 78. There's my maximum. But this is a word problem, so I need to say 3 belts and 2 wallets. And that's it. And we have one more for practice. This is it. Here we have a diet is to include at least 120 milligrams of vitamin A and 210 of vitamin B. These requirements can be found from 2 types of food. Type X contains 10 milligrams of vitamin A and 30 of B per pound. Type Y contains 30 of A and 15 of B per pound. If X costs $12 per pound and Y costs $8 per pound, that's going to be my objective function right there. How many pounds of each type should be purchased for the minimum cost? Okay, so in this case, we have, well, this is not too exciting here. X is type X and Y is type Y. So X and Y, X and Y. Now we have vitamin A and vitamin B. The breakdown says X has 10 of A and, wow, that was horrible, 30 of B. Y has 30 of A and 15 of B. And we're going greater than or equal because we're doing a minimum. And it was 120 and 210. So our objective function, once again, was from the cost per pounds. That was 12x plus 18y. Sorry, 8y, not 18, 8. My constraints always start off with this, which basically puts in the first quadrant like we see below. And then we just read across. 10x plus 30y greater than or equal to 120. 30x plus 15y greater than or equal to 210. Once again, you have the choice between solving for y or doing the cover-up method. These are all nice numbers, so I'm going to do the cover-up method. So 120 divided by 30 gives me a y of 4. And again, for some reason, this one did not print properly either. So we'll just add an axis right there. And we'll go y of 4. 1, 2, 3, 4. Go back up. Cross out my y. That gives me an x of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right here. Whoops. I gotta count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right there. And we're going to connect those. And if we want to do the shading this time first, we can. So again, if I did this, I would get 0 is greater than or equal to 120. That's a lie. That's not true. So I'm going to shade everything above this line. All right. Now, I'm going to come over here and do this one. Cover up my x, right? Do 210 divided by 15, which is 14. So my y is 14. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Here's that one. Come up here now, cross off my y, which gives me x. Okay. 21 divided by 3 is 7. So x is 7. 1, 2, 3, 4, 5, 6, 7. Right here. And I'm going to connect those dots. And I'm going to do my test. And I end up with 0 is greater than or equal to 210. Definitely not true. So I'm going to shade above this line. Or, not 0. So where's my overall line? It starts here, comes down here to this point, out to this point right here. Those are my 3 corner points. So what is that mysterious point? 1, 2, 3, 4, 5, 6, 1, 2. And again, this one was 12, 0. And this one was 0, 14. So those are my 3 corner points. 0, 14, 6, 2, and 12, 0. If I plug those into my objective function, I get 112, 88, and 144. We're trying to minimize costs. Okay? So it's 6 and 2. So it says how many pounds of each type of food. Okay? So that's 6 pounds type X and 2 pounds type Y. And that's it.